Last time I cleaned all the main parts of the Unimat SL. This time I'm going to disassemble the tailstock and the spindle and sort out some of that rust. Welcome to Adventures with a Very Small Lathe. I postponed disassembling the tailstock until the worst of the mess was out of the way. It's mostly held together by the two grub screws at the top. The screw at the back is a regular rotating screw and holds the feed mechanism in place. The screw further forward has a flat square end which sits in a keyway to help keep the quill aligned. With both screws removed, it should all come free. The quill comes out without difficulty once it's free of the lead screw, but the screw mechanism seems pressed in and caution is required. The caphead screw at the back is used to lock the quill and should have nothing to do with freeing up the feed. Pulling on the handle didn't seem to do much to free it, but I was careful about how much force I used. Careful taps with a hammer are safer than attempting to pull clear with force, as it's less likely to come apart unexpectedly and better control of energy delivered. If I had a piece of wood a suitable size and shape, that would have been ideal to make sure I didn't do any damage, but all I had was a bit of bar stock which did the job. The bushing which aligns the screw in the tailstock casting is captured between the main part of the screw and the handle, so should come free when the handle is removed. The feed handle is exactly like the others on this lathe, and like the others, Grime and H have stuck the lock nut in place. As for the other handles, WD-40 helped shift it pretty quickly. All the unpainted parts can go into the ultrasonic cleaner while I work on the painted casting by hand. I'm reusing the solution as it still seems to have plenty of life left. I reheated the solution first and used fresh hot water in the ultrasonic cleaner's tank. You can clearly see the oil and dirt billowing off into the solution. WD-40 seems to have worked on the other painted parts, so I'll use it again on this one. The pipe brushes aren't all that great at shifting the black grime, but the brass wire brush is more effective. Some of the paint is clearly wearing away, but it looks like it isn't much tougher than the grime, as not all of the dirt is gone yet, so I guess some paint wear is unavoidable. The pipe brush is perfect for cleaning out the bore. Slots like this one all over the lathe are some of the most difficult parts to clean, and it looks like something is wedged in here real good. The deep voids in the casting also have dirt right at the bottom, which is hard to get to. There turns out to be a washer in the slot, which I think is there to prevent over-tightening from breaking the casting. Just like the saddle, there's a lot of dirt packed into the slot, which is tough to reach with a brush. A scrap of cardboard helps move most of it, which is less risky than using a metal shim next to the bore lining. The rest of the parts have had plenty of soak and ultrasonic time and come out pretty clean. There's a bit of surface rust on the end of the tailstock quill, which I'll have to sort later. Just as before, I dry with a tissue, then spray with WD-40 to displace the last traces of water and protect from corrosion. It's important to fully cover the inside and outside surfaces of the quill, as water could easily get left in the inner thread or keyway. The spindle is the biggest challenge of the whole disassembly, as it's the easiest place to screw something up. Contamination inside the spindle would cause runout or uneven motion, so should be avoided. To keep chances of contamination to a minimum, I brush away as much surface dirt as possible before I start disassembling. Like the other steel parts, it's not obvious whether this is caked on brown oil or grease or corrosion. The toothbrush makes a good start, but can't seem to shift the more stubborn dirt. That bit there feels fairly hard and could easily be a spot of corrosion. With the brass brush, most of the dirt seems to dissolve and brush away, but there are spots which look like more stubborn rust. The keyway catches grime very easily, and I want to make sure as little heavy dirt is left as possible before I open up the bearings. Now the bulk dirt is removed, I clean down the bench before exposing the insides. It's absolutely vital to place close attention to how the parts go together. Saar, over at smallathe, sent me some useful warnings on how the spindle can easily go together incorrectly. His video on an easy mistake to make is at the top right now. The bearings are packed with grease, so I'm going to use a tissue to stop the grease from getting everywhere and reduce the dirt that gets stuck into the bearings. The rear of the two bearings is loose on the spindle shaft and slides off easily. Note that the side of the inner race facing outwards was the one with the text on it. The shaft now lifts clear of the spindle housing, and we can see there's a spacer tube on the shaft between the inner races. This is common in spindles designed with angular contact bearings, so I'm guessing that's what this is. Note there's a small but noticeable taper at the rear end of the tube, but not at the front. The outer race of the rear bearing pops out easily enough, along with what looks like two thin steel washers. The washers are slightly conical and rest together with the inner edges touching, so these are probably springs used to preload the bearings. Now I can see one of the outer races. It's clear the bearings are angular contact, but I've never seen a pair with separate outer races before. The front inner race seems to be pressed onto the shaft, and there's no obvious way to remove it without damage. The front outer race also seems to be pressed into place, but there isn't an obvious need to remove it as long as it's clean and in the right place. I'm going to wipe off as much grease as possible before ultrasonic cleaning, so the solution has less work to do, which hopefully will make it more effective. The bearings need to be cleaned to the highest standard, so I mixed up a completely fresh hot solution in a clean jar. The water in the cleaner tank is freshly boiled to make sure the jar doesn't cool down too fast. This is the best view yet of cavitation pushing the grease out of the teeth of the rack and breaking it up into solution. After running the cleaner for a full cycle, I turn the larger parts over to make sure every bit of them gets proper coverage. After the second run, I remove them from the cleaner, drain off the solution, and this time I'm going to try using a heat gun to get rid of the moisture. The heat gun temperature should be safe. This kind of home improvement heat gun could theoretically be hot enough to affect the temper of the steel, but in practice it would be difficult to get it to reach that high. Finally, a coat of WD-40 to displace the last traces and protect the steel from corrosion in the air. The chuck is in terrible condition. The lubrication is almost completely dry and there's lots of surface rust. It needs to be fully disassembled to clean it as it has fairly complicated internal parts, but I'm missing a key tool I need to just do the disassembly. This circlip on the back needs a pair of circlip pliers to remove. If I had a full set of tools available, I would probably be able to improvise, but I haven't been able to get something to work with the limited tools I have, so I'm going to put this to one side until I have the right tool for the job. The final part of the spindle assembly to look at is the aluminium drive pulley. It looks like it's in pretty good condition, but it has some dirt build-up on the surface near the spindle bearing. A brush with some WD-40 seems to work pretty well and removes a lot of grease. It leaves behind some discoloration which appears to be in the anodization of the aluminium, so I don't think I can easily remove it. This brings cleaning every part of the lathe to an end. Now everything is clean, I'm going to see what I can do about the rust on a handful of parts. For this I'm going to use Evaporust, which is a very safe, non-toxic rust remover. It's intended to work without risking further damage to the metal, which could easily occur with acid-based rust removers like vinegar. There's one side effect of using Evaporust that I want to avoid though, which we'll talk about in a moment. All the parts have been left with a coating of WD-40, which would contaminate the Evaporust and prevent it from reaching the surface, so before I start I'm going to degrease with isopropyl alcohol. The first three steel parts I want to clean up are the fixed tool post, the cross-slide block and the spindle housing. Parts left in Evaporust for a long time tend to lose their bright steel finish and turn grey. For very rusty parts that isn't a problem as they don't have a bright surface, but the parts I'm looking at today only have rust spots, so I'm leaving them in the Evaporust for the minimum time necessary to do the job. The spindle housing is the most important. The outer surface slides inside the headstock bore and is critical for alignment and strong rigid holding. There's relatively little rust spotting and only a very few are rough or raised areas. Brushing in Evaporust seems to work great and a lot of the thin surface rust clears quickly. The cross-slide and tool posts have quite a lot more rust and it doesn't seem to work as quickly, so I'll leave them in a bit longer. There are some larger spots left, so I'll try using a bit of Scotch-Brite to work on those bits. Once the surface feels smooth, I wipe it down and dry the steel with the heat gun once again, and reapply the protective WD-40. Once again, I need to be totally sure I get every part of the surface and there's no water lingering behind. The cross slide is a lot more rusty and highly visible. There's also a practical reason why I want it to be rust-free. The top surface is the mating surface for the tool post, and it must be flat and clean to make sure that the tool post stays rigid. The two bore holes also need to be smooth, as they act as the slideway for the cross slide. It takes some scrubbing to clean, but the rust is coming off way more easily than I think it would without the evaporust. For the same reasons as the cross slide, the tool post needs to be clean and free of rust. It's clearly the most rusty of the three parts and also the most difficult to clean, so I'm going to leave it in the evaporust to soak. The cross slide is looking pretty good, so I'll dry it off and coat it in WD-40. After an hour in the evaporust, the tool post is looking better. Scrubbing with Scotch-Brite seems to shift the rust pretty quickly, but the shape makes some of the bits hard to reach. The screws are still stuck in place, and I haven't decided whether I want to cut them out and replace them yet. The main blocker is making sure I have the right replacement screws before I start, or I'll be without a usable fixed tool post. To make sure there isn't water stuck in the threads, I need to use a heat gun and WD-40 pretty thoroughly. Letting the screws get rusted in place would be annoying. The final parts to fix are the bed rails. Most of the surface is pretty good, but there are a few areas affected by rust spots, and some of the spots are quite large and raised. I decided to try this oak strip to rub at the rust, as the wood should be stiff enough to have an effect without being hard enough to damage the metal. This seems to work moderately well. I'm not going to rush it, as it takes time for the evaporust to work. After most of the rust is cleared, I switch to Scotch-Brite for the more stubborn areas. Keeping the slideways smooth and undamaged is key. Smoothness will keep the lathe running easily, but damage would reduce precision. I'm using very little pressure on the Scotch-Brite to avoid damage, but over time it's still removing the rust. The second bed rail has significantly worse corrosion. There's a particularly large stub and rust patch here which is raised well above the surface. It's going to be tough to remove and will probably leave some pitting. In the end I was racing against the fading daylight to get this done, as I don't have decent electric lights in this shed, but I finally got the rails looking good before I lost the light completely. Everything is now clean and rust free and I can't wait to put it together, but I'm out of daylight and this video is already too long. Stay tuned for the next one where I'll put the lathe back together and try it out. Thanks for watching, take care, I love you all.